New topic is trade. Okay, first, production possibilities and trade. This is going to start with a very simple model of what is possible for someone to produce. I'll talk about just an individual person in the beginning. Okay, here is a very simple model of a student studying. Okay, this student has two exams tomorrow, an exam in economics and an exam in biology. And the student has 4 hours available tonight. Okay. And I want to talk about what the student's options are. Okay. So I've written up this kind of simple little thing about how each number of hours would translate into a grade. If this student spends 1 hour studying biology, the student will get a 40 on the biology exam. The student spends 2 hours, the student will get a 70, and so forth. Does that make sense? Okay, now the student has limited time, right? Time is a scarce resource, and the student faces a trade-off. The student faces a trade-off between doing well on the economics exam and doing well on the biology exam. Okay. Gee, people face trade-offs. Do you recognize this trade-off? Face it all the time, right? Okay. So let's talk about what's possible for this student to do. The student's options. First of all, is it possible for this student to get 100 on both exams? No, right? Not possible. If the student has 4 hours tonight, there's no way the student can spend 4 hours studying biology, 4 hours studying economics. That doesn't work. Okay, so let me start graphing some of the options available to the student. So for example, this student could spend all of the student's time. Let me first talk about right here. Student could spend 4 hours studying economics, 4 hours of economics plus 1 hour of biology. No biology. Plus 0 hours of biology. Okay, the student does that, the student will get a 100 on the econ exam and 0 on the bio exam. So I'm creating this graph. On one axis, I have the grade in economics. On the other axis, there's a grade in biology. Okay, and here's one point that I can graph. Okay, now another option is spending 3 hours studying economics and 1 hour studying biology. Okay, which means that in econ, the student would get a grade of 90%, and in biology, a grade of 40%. Okay, so I've plotted that point right here. Makes sense? Okay, and then I'm going to continue. Another option available to the student is spending 2 hours on econ and 2 hours on biology. And so that gives a grade of 70 on each. Okay, so that's this point right here, 70 on econ, 70 on biology. Okay, and I'll continue to graph out these points that are available to the student. And once I graph them all, here they are. Okay, got it? Okay, here are options. Now, often we will just complete this set, just connect the dots. Okay. Student can choose these options along here, more or less. Okay, these are the things that the student can produce in terms of grades on the two exams. Okay. What we call this area, or this upper bound, is the production possibilities frontier. Okay, so here, I've done a neater drawing of it with straight lines. This blue upper bound is called the production possibilities frontier. To translate this name, production, things the student can produce. Okay, possibilities. These are things that are possible. But for example, getting 100 on both exams, that's not possible. Okay, and frontier, like upper limit. Okay, so this blue represents the boundary on what's possible for the student to produce. Okay, and again, production possibilities frontier. It's an important concept in trade. Let me point out a point inside the production possibilities frontier is possible. It's possible for this student to get 40% on econ and 40% on bio. I think if the student spent an hour, the student could get 40. So the student could get a 40 on both exams. But this is inefficient, okay? So it's possible, but inefficient. Okay? And by the way, the model is a simplification of reality. These are the only two things the student can do with the student's time. Okay, so the alternative is just sit and stare at the wall. Okay, there's nothing to do with the remainder of the time. So spending an hour on studying each activity is inefficient because a student could improve both exam grades by studying more. Now, things outside the production possibilities frontier. So, for example, getting a 90, let's see, getting a 90, why can't I draw a line down to 90? Okay, here, 90% on econ and 90% on biology, that's simply not possible. Okay, it's unattainable. It would require spending 3 hours studying each subject, 6 hours total, and the student doesn't have that much time tonight. Okay, but the points exactly on this border, okay, those are the limits to what the student can produce. Okay, those are the efficient decisions. Does that make sense? Now, I've talked about this in terms of what a student can produce. The same kind of thing would be true of what a whole country could produce. Okay, change the grade in econ and grade in biology to the amount of good one, amount of good two that a country can produce, and it has some limited resources. As a matter of fact, I'm going to talk about guns versus butter. Okay, I know you all love my artistic skills, right? Okay, a country has a choice to produce guns or butter. This is, in fact, an example that dates back to the late to the late 1800s. A politician named William Jennings Bryan. Has anyone heard of William Jennings Bryan? Okay, a couple of people. What's your association with him?
Just like a populist politician.
He was a populist politician. Okay. Anything more? Shall we crucify mankind upon a cross of gold? Does that sound right? Yeah, that was another of his lines. Yes, so he was a populist politician. Let's say sort of the Bernie Sanders of the late 1800s. Um, he tried to do economic policies or push economic policies that would help the common person. One of them was um, the, one of them was expanding from using just gold as the basis for currency to also making silver a precious metal that was traded. So going from simply the gold standard to what was called a bimetallic standard. And so adding more money to the economy would result in inflation, but also it's like giving money to the common people. So it was bad for the people who were hoarding large amounts of gold, the rich people, but it was good for the common person. Yes, that's the thing about gold versus silver. A populist, again, he appealed to the common person. He also had a saying about guns versus butter. Okay, a country could use its resources to produce guns or butter. Why this distinction? Is an old thing that goes back, like, countries have had to deal with this, well, with decisions about how to use their resources. And in particular, does a country, like, this has been a decision for as long as countries have existed. Should the country use its resources to build up an army or use its resources for kind of domestic policies? And William Jennings Bryan described these as guns or butter. How were we to use the United States resources? Do we want to invest in guns so we can go to war, or butter, like domestic production of food? And there is, in fact, a reason why these things are linked. Okay, and there's something. So this is unimportant trivia. There is one resource known as saltpeter, or niter. It's potassium nitrate, um, that that is useful for producing either gunpowder. It's one of the three important ingredients in gunpowder, but it's also a potent fertilizer. And in the late 1800s, people were just starting to understand the role of adding fertilizer to make crops more productive. Okay, so they realized that this potassium nitrate stuff could be converted or could be dumped in the fields and grow more corn to feed to the cows, who would produce more butter. Okay, but again, the same potassium nitrate can be converted into gunpowder to go to war. And a country like and potassium nitrate was a valuable international resource at the time. Okay, countries went to war over reserves of potassium nitrate. Now, if you notice, uh, you notice up here, see something above that potassium nitrate? This little thing. Okay, can anyone guess what that's supposed to represent? Yes, a bat. How do bats factor into this? Doesn't their poop produce it? It's called guano, and yes, bat guano. Okay, you're very good. You're on a roll right now. Bat poop is this valuable resource, potassium nitrate, and can get converted into one of those two things. So anyhow, this is a long story that is mostly not directly related to economics or to this course, except it really illustrates that a single resource literally can be used for one of two purposes: either build up domestic agriculture or build an army. Okay, and yes, bat poop was this precious commodity. The U.S. went to war with other countries over access to bat poop, and it was a big deal in the late 1800s. Okay, so let's imagine two countries. Trade between, I'll just say, the United States and Canada. Okay, here is, let me just set up the United States. The United States has 1,000 tons of saltpeter. And U.S. factories can produce, let's say, 2 boxes of guns with each ton of saltpeter. Or farmers can take a ton of saltpeter and convert it into 1 crate of butter. Okay, it's a simplified example. And the numbers are not intended to be realistic. They're trying to convey concepts. Okay, so the country has some resources, and here is production in the country. Now, in some ways, this is like the student who studies and has a trade-off how the student wants to use the student's scarce time. The country has a trade-off in how to use its scarce saltpeter. And we can graph the production possibilities available to this country. At one extreme, often I think of the extreme points. At one extreme, if the U.S. uses all of its saltpeter to produce guns, it can produce 2,000 guns, but 0 butter. Okay, so that's this point right here. The other extreme, if it puts all its resources into producing butter, all 1,000 saltpeter into producing butter, it can have 1,000 butter, but no guns. And it could do something in between. So like it could spend 500 saltpeter to produce 1,000 guns, and the other 500 to produce 500 butter. So 500 saltpeter can produce 1,000 guns plus, and then the other 500 are used to produce 500 butter. Okay, so that's like this point right here. 1,000, 500. Okay. And there are other options. Spend 250 to produce butter, and then the remaining 750 will produce 1,500 guns. Okay, etc., etc. In this case, it's just going to be a straight line connecting the two extreme points, okay? Because there's this fixed trade-off between between guns and butter. Okay, so here, this line is the production possibilities frontier for the U.S. Okay, it's a straight line going from these two extreme points. All right, and then the U.S. can choose. Okay, oh, well, yeah, here is the neater version of this. Again, this is the production possibility frontier. The U.S. can choose to produce anything along this line. Now, if the U.S. is acting on its own, no trade with Canada, it consumes what it produces. Okay? So, just pick an arbitrary point, okay? For the sake of this example, let's suppose that the U.S. spends half its resources to make guns, the other half to produce butter. And so the U.S. is producing 1,000 guns, producing 500 butter, and if it's on its own, it consumes what it produces. Okay, now let's flip over to Canada. Okay, production in Canada. Canada is going to be a little bit different. Um, Canada also has 1,000 saltpeter, but I'm going to make something a little bit different. In Canada, each factory can convert 1 ton of saltpeter into 1 case of guns, or the farmers can convert 1 ton of saltpeter into 2 butters. Okay. Again, production is a little bit different in Canada. Maybe, and so uh, specifically, a ton of saltpeter could produce more guns in the US than in Canada. Maybe American factories are just more productive at making guns. Maybe Americans have better technology for producing guns. The farms are also different. 1 ton of saltpeter can produce 2 crates of butter in Canada. 1 ton of saltpeter can produce just 1 crate of butter in the US. So it's like Canadian fields are more fertile or able to do more with the with the fertilizer than American fields. So the production is a little bit different. Still, there's a production possibilities frontier for Canada. And at one extreme, if Canada uses all its resources to produce guns, it can convert the 1,000 saltpeter into 1,000 guns. Okay, but it has nothing for butter. The other extreme, it uh, it can use all of its resources for butter, and it has 2,000 butter but 0 guns. And anything in between is also possible for Canada. Okay, so here's the production possibilities frontier for Canada. And let's just say, for the sake of this example, Canada uses half of its resources to produce guns, so that's 500 guns, and half of its resources to produce butter, so that's 1,000 butter. Okay, and on its own, Canada consumes what it produces. Okay, so here I've set things up where the U.S. is just doing its own thing, Canada's doing its own thing, and maybe keep in mind the U.S. doing its own thing. They're making 1,000 guns, eating 500 butters. Canada, 500 guns, 1,000 butters. And what I want to demonstrate is that both countries will do better if they um, trade. Okay, so let me move on to that example and think about the production possibilities of the U.S. and Canada combined. So I'm going to graph out some of these choices. Okay, remember each country had 1,000 saltpeter, and if both countries decided all they will produce are guns, the US produces 2,000 guns, Canada produces 1,000 guns, so together they can produce 3,000 guns, but then no resources left for butter. I'm going to mark that as one production possibility right here. Okay, so this is where both countries produce only guns. It's possible for them to produce 3,000 guns and 0 butter. Okay. Another extreme point, if both countries decide to use their resources to produce butter only, the US, if it uses all 1,000 saltpeter for butter production, produces 1,000 butters. Canada, if it uses all its resources for butter, produces 2,000 butters. So combined, they can produce 3,000 butters. Okay. Now, let me point out another possibility. What if one country does only guns, and the other does only butter. Okay, what would that be like? Well, there are two ways we could do that. One is ask the U.S. to produce only guns and Canada only butter. Yeah. So then, how many guns would they have together? 2,000. And how many butter would they have together? 2,000. Yeah. So I'm going to graph that point here. Okay. Right here, I think that's 2,000, 2,000. Okay. Now, okay. So that is certainly a possible point. That is certainly part of the production possibilities frontier. Now, the other way that we could have done that is we could have asked Canada to produce only guns. Canada would make 1,000 guns, and the U.S. make only butter. So the U.S. makes 1,000 butter. That would be this point down here, right? 1,000, 1,000. That is inefficient because if they swap who does what, they will have more of both resources. So this is feasible, but inefficient. Okay, now, so it's clear that if each country focuses on just producing one good, U.S. would focus on producing guns, Canada would focus on producing butter, and we certainly have this point, 2,000, 2,000, as part of the production possibility frontier. As a matter of fact, the entire production possibility frontier looks like this. Okay, so we have the 3 points that I discussed earlier. Both countries produce only guns. Both countries produce only butter. Each country focuses on producing only one. But then there are also other options, like the U.S. Just for example, U.S. could produce, well, if it uses 500 on guns, that yields 1,000 guns, and the other 500 on butter, that produces 500 butter. Right, that's something the U.S. could do. And then Canada just uses all 1,000 saltpeter on butter. Then that would be 2,000 butter. And so when you add them together, that would be a point like 2,500 butter and 1,000 guns would be feasible. Okay, and what I'm doing right here is explaining why the production possibility frontier is not just simply those 3 dots, but also the line segments in between them. Again, this point right here on the line segment, that's 1,000 guns, 2,500 butters. That's something that the two countries together could produce if Canada produces only butter, the U.S. produces half and half, or uses half its resources on guns, half on butter. Anything along this upper surface is possible, and that is the production possibilities frontier. Okay, Now, let's just suppose, again, for the sake of this example, that the U.S. Produces only guns, Canada produces only butter. So that means the two countries together are producing, combined, are producing at this point right here. Then they trade. And the US gives 800 guns to Canada, and Canada gives 600 butters to the US. Again, it's just an example. I'm coming up with numbers. I'm kind of making these up to illustrate the following point. Then, let's see, how much does the US end up with? It produced 2,000 guns, gave 800 to Canada, so it's left with 1,200 guns. It produced 0 butter, but it got 600 from Canada, so the US can then consume 600 butters. Does that make sense? Here. Okay. I might be missing a slide. Okay, so the US consumes 1,200 guns plus 600 butter. And Canada, after they produce and trade, Canada consumes, let's see, they got 800 guns from the US, and they are left with 1,400 butter. Okay, so this is what they can do with trade. Okay, let me compare that to what they did without trade. Okay, without trade, the US consumed 1,000 guns plus 500 butter. And Canada consumed 500 guns plus 1,000 butter. Okay, the US is better with trade than on its own, right? The US has more guns and more butter after trading with Canada than it could have produced on its own. This point, like what the US is consuming with trade, 1,000 guns plus 600 butter, that was above the production possibility frontier for the US. The US could not have produced 1,200 guns and 600 butter on its own. Okay? But it can if it trades with Canada. And the same thing is true for Canada. Canada on its own could produce 500 guns and 1,000 butter, but it could not have produced 800 guns and 1,400 butter. That was above Canada's production possibility frontier. So what Canada can consume after trading with the US is more than it could have consumed on its own. Okay? They have more guns and more butter. Both countries have more guns and more butter if they focus on doing what they are good at doing and trade with their partner. Okay? Trade can make everyone better. That's why we do it. Okay? So I've told a story here about international trade. I'm going to move next to a little story about trade between people because it's the same thing. Okay? We can talk about the politics, or we will talk about the politics a little more on Thursday, because it seems that international trade is a controversial topic. Every election cycle, we hear politicians talking about trade deals with other countries, like tariffs with China, renegotiating NAFTA, another trade agreement. And that trade, we hear politicians talking about the negative aspects of trade. However, countries are better off with trade and without limitations on trade. If I talked about this on a personal level, like two people trading, maybe it seems less controversial. So let me talk about that example. Oh, okay. We have two people. I call them Mr. Plum and Ms. Green. Okay. See, again, these economic models are very simplified versions of reality. There are 250 working days in the year. Okay? 50 weeks times 5 days a week, 250 days in the year. 2 weeks off for vacation, I guess. Okay, each day, these two people can do, well, each day a person can do one of two activities, either teach or sew shirts. Um, so, uh, but the two people are different. Mr. Plum knows enough and is a good enough teacher that he can teach 5 classes. Ms. Green could teach 6 classes in a day. She's, I suppose, a more efficient teacher. Mr. Plum could sew 2 shirts in a day. Ms. Green could sew 3 shirts. Okay, now, so I'm thinking of like different people in society, and we all have different roles. Some of us are teachers. Some of us make clothes. Some of us grow food. Some of us are doctors, lawyers, movie actors, factory workers. Everyone has different occupations, and I'm simplifying this to 2 occupations. Okay, one possibility is that each person just focuses on what the person can do at home. If I'm Mr. Plum, I think about my 250 days in the year. So let's go to a graph. I'm going to graph out number of classes that I could teach versus number of shirts that I could produce. Remember, I have 250 days in a year. Each day I can teach either 5 classes. So that would mean at one extreme, if I spend all my time teaching, 250 days times 5 classes a day, I could teach 1,250 classes in a year, but then I would have no shirts. The other extreme, I can make, what was it, 2 shirts? It was 2 shirts in a day. So if I spend all 250 days making shirts, I could make 500 shirts in a year. But then I would do no teaching. And anything in between is possible as well. Okay, so here's a production possibility frontier. That's supposed to be a straight line. I'm trying to keep this very simple. Okay. So, yeah. Okay, drawn a little bit more neatly. Here are the things that Plum can produce on his own. And then Plum picks a point. So let's suppose, that Mr. Plum decides he's going to spend 100 days of the year teaching classes and 150 days sewing shirts. So then that means that Plum can produce 500 classes. Okay, so here's 500 and 300 shirts. Okay, so that's this point right here. Yeah. Okay. So that's his decision. And realize if Plum is acting on his own, he consumes what he produces. He consumes those 500 classes and 300 shirts. Okay. Then, Ms. Green. I'm going to think about her options. So I set up my graph. On one axis, I have number of classes taught in a year. The other axis, number of shirts sewn in a year. Okay. And then I graph out Ms. Green's options. So remember, she could, in a day, she could produce 6 classes or 3 shirts. Okay, so if she spends all her time teaching classes, then in a year she can teach 6 times 250. So that's 1,500 classes, but she has no time to sew clothing. The other extreme, she could spend all her time sewing shirts and make 750 shirts in the year. But then teaches no classes. Okay? And the points in between are possible as well. So here are Green's choices, and she selects something along her frontier. So maybe she decides she's going to spend half her days teaching, half her days sewing shirts. That means she can, let's see, 125 days teaching classes times 6 classes per day means that she produces 750 classes. She spends 125 days sewing shirts times 3 shirts per day, which means that she produces 375 shirts. Okay, so that's what I've written down below. She produces 750 classes, 375 shirts, and if she's acting on her own, then she consumes what she produces. Okay, in the next step, we're going to think about what Mr. Plum and Ms. Green could do if they worked together. Plum and Green working together. Now, the extreme points, I'm going to graph this, and usually it's easy for me to think about the extremes first. If both of them spend all their time teaching, Mr. Plum can produce 5 times 250 equals 1,250 classes per year plus 0 shirts. If Green spends all of her time teaching, that's 6 times 250 equals 1,500 classes, but again with 0 shirts. So add those together, 2,750 classes. That's one point that is on the frontier. The other extreme point, I calculate what would happen if both of them spend all their time sewing shirts. So that was sewing shirts only. That was what was that? I'm blanking right now. 3, 4, 2 and 3. Yeah. Okay. If Plum spends all of his time making shirts, that's 2 times 250 equals 500 shirts plus 0 classes. If Green spends all of her time, that's 3 times. She can make 3 shirts in a day, so that's 3 times 250 equals 750 shirts plus 0 classes. So add these together. Another possible point is 1,250 shirts plus 0 classes. And that's this point that I've graphed right here. Okay, now the next thing is maybe I want to think about Suppose we were at this point where everyone is teaching all day long, but then we decide, oh, let's produce a shirt. Okay. So going from 0 shirts to 1 shirt. Here's the question. Who would do it? Okay. If we want to produce 1 shirt, should Plum produce the shirt or should Green produce the shirt? Okay. So if we want to go from 0 shirts to 1 shirt, that's an arrow right there. Who produces? Well, we have to think about what we would give up if Plum produces a shirt. That means half a day less teaching, right? Takes Plum, it takes Plum, or Plum can make 2 shirts in a day, so Plum gives up half a day of teaching, which means that they give up 2.5 classes. Okay. Then, if Green produces 1 shirt, she has to give up 1/3 of a day. She has to take off 1/3 of a day from teaching. So 1/3 of a day less teaching. And so she could teach 6 classes in a day. So in 1/3 of a day, she would have taught 2 classes. So that means that they give up 2 classes. Okay, so these people together want to produce 1 shirt. If Green does it, they give up 2 classes. If Plum does it, they give up 2.5 classes. The cost is lower if Green produces it. So Green produces at lower cost. Produces the shirt at lower cost. And so she should produce shirts. Okay. When there's a choice. Okay. If there's a choice between should Plum produce a shirt or should Green produce a shirt, and they both have the time that they could spend on it, Green should produce it. Okay, got it? Okay, so we're done for now. I will continue talking about this on Thursday.